When we hear solar system, we immediately think of it as a home containing one big family of powerful celestial objects. We look at its arrangement in awe as they work in harmony to, well, for one thing, keep us alive. But what happens when one planet threatens to destroy that harmony? Welcome to Factnominal, and in today's video, we're going to see why the planet Neptune is a possible threat to our entire solar system. Let's look at Jupiter, Neptune's bigger cousin and the largest planet in the solar system. What do you think would happen if it mysteriously disappeared from our solar system? For starters, there would be minor orbital changes with other planets that revolve around the Sun. Yes, but the most threatening aspect of its disappearance is the millions of pieces of debris that would eventually crash into the Earth and would bring mankind to its end. That is terrifying, isn't it? So, what would be the fate of the solar system if something were to happen to Neptune, a planet with 14 moons and that is 4 times larger than Earth, a planet we humans have very limited information about? Well, strap your seatbelts on because we're taking a blast to the past. In the year 1687, the English physicist and mathematician Sir Isaac Newton published his book, The Philosophiae Naturalis Principia Mathematica, which helped in predicting the orbits of planets around the Sun. Since then, scientists have learned that the solar system is just one tiny point of light that revolves around the Milky Way galaxy's nucleus. This means that occasionally, our solar system will pass in front of other stars, and this can generate a violent disruption that can knock planets off their orbits. Yikes! This phenomenon we just explained is known as stellar flyby, and according to our men in white coats, this is a common occurrence. Scientists believe that the occurrence of a stellar flyby is an important event that must occur for the evolution of the planetary systems. Although scientists are still looking for evidence of significant changes in our solar system caused by a stellar flyby, given that the majority of the changes most likely occurred 4.6 billion years ago, one could argue that evidence of a stellar flyby has been lost in time. Or has it? The solar system has been in existence for about 4.6 billion years, and it's maintained a stable gravitational system during that time. Such stability would not have been attainable if the planets were always in a state of constant chaos. If this were the case, the alignment of the planets would be ruined by such disturbance, which would be devastating. This happens because the solar system depends entirely on the gravitational pull the planets have on each other. Now, here's where Neptune comes in. Neptune is the furthest planet in the solar system, with a distance of about 4.47 billion kilometers away from the Sun. This also makes it the most vulnerable planet and, of course, an easy target. But an easy target for what? As we all know, the solar system is not an isolated planetary system. It's a part of the Milky Way galaxy that's filled with asteroids, stars, meteoroids, and gases, some of which might be harmful to a planet, and it's all in continuous motion. So what does this mean for our dear old Neptune? In a hypothetical sense, the planet Neptune would be the first planet to feel the effects of a stellar flyby, and that is a problem. So, 2 scientists at the University of Toronto performed over 3,000 simulations with varying degrees of disruption. This experiment was based on what would happen if a stellar flyby occurred. They assessed the consequences for up to billions of years in the future. Take a guess. What do you think they found out? These Canadian scientists discovered that major adjustments to Neptune's orbit are required to be on the order of 0.03 astronomical units, or 4.5 billion meters, to have any influence on the solar system's long-term stability. This sort of alteration to Neptune's orbit could increase instability up to tenfold during the lifespan of our solar system. They also theorized that if a neighboring star happened to fly too close to the planet Neptune, it would cause a shift in the planet's orbit, which could further destabilize other planets in the solar system. And guess what? That's not the only scary thing about this. If such were to happen, well, the passing star would not need to be as big as the Sun to do damage. And the part that makes this crazier is that due to the distance of Neptune from Earth, we may not see it coming until the damage has already been done. Oh boy. Learning about this has troubled scientists worldwide, so much so that they want to know when we should be expecting a passing star. But sadly, figuring that out has posed a significant challenge to scientists. You're most likely now asking why. The answers to that rest in a predicament that astronomers have struggled with ever since Newton formulated his theory of universal gravitation. To summarize, it all boils down to the n-body issue, which describes the difficulties of predicting the individual path of a group of astronomical objects interacting gravitationally with each other. Solving this accurately is mathematically impossible, and that leads astronomers to adopt numerical approximations. But there's a problem. The difficulty with adopting numerical approximations is that, first, the motion of the planets is unpredictable, meaning that modest changes in the system's initial conditions would have a big impact on the results, even differences as small as 1 part in a trillion. Second, the timeframes are very dissimilar. The use of numerical solutions can give scientists an estimate of the number of simulations that will eventually become unstable versus the number of simulations that won't. However, dealing with timescale problems remains a difficult task because the planets must be simulated one day at a time, necessitating massive computer resources. Even at the speeds that modern computers are capable of reaching, such simulation may take as long as 3 to 4 weeks to complete. All of this may lead us to conclude that Neptune is the only planet that could pose a threat to our entire existence. But there's more. In January 2015, a pair of scientists from the California Institute of Technology proposed that a Neptune-sized planet circles our Sun in an extremely elongated orbit that far outstretches Pluto. They made their argument primarily on mathematical modeling and computer simulations rather than on observation. The unseen planet is predicted to exist based on its apparent gravitational influence on a group of small objects with odd clustered orbits. According to the hypothesis, the planet has a mass around 10 times that of Earth and an orbit approximately 20 times further from the Sun than Neptune, the 8th and farthest known planet from the Sun. Dr. Whitmire, a retired professor of astrophysics who taught at the University of Arkansas, claimed that Planet 9 may be the cause of comet showers, which have the potential to wipe out our planet and most likely others. According to Dr. Whitmire's findings, a big planet dislodges comets every 27 million years, which has the potential of causing massive extinction. However, there's no proof that any known or hypothetical object poses a threat to Earth, but observers are keeping a close check on near-Earth objects for possible issues. Furthermore, after running simulations, scientists from the University of Toronto concluded that a star would not pass by and disrupt our solar system for another 100 billion years. Phew! I was getting worried. I love my planet. A little secret: it's my favorite. Although it is quite sad that our beautiful planet Earth is constantly being threatened by a variety of existential dangers, such as nuclear war, a pandemic, and extreme climate change. But these terrifying scenarios are insignificant to what some scientists predict for Earth. Our planet's ultimate fate, based on their assumptions, is to be annihilated. Most likely a few billion years from now, when the sun will expand and swallow the planet. There may be nothing we can do to avert plausible impending disasters. However, according to experts who research the far future, such as Yale University astronomer Gregory Laughlin, the prognosis for life is strangely rather bright. Given technological advancements and our species' ongoing development, humanity should be able to endure, in some way, long after our solar system ceases to exist. But of course, our distant descendants are gonna have to do some planet hopping. To dwell in the outer solar system, would-be settlers most likely have to abandon living on surfaces of planets and moons in favor of revolving stations in space. These would give potential residents all the facilities they require, while also overcoming the most significant hurdle to long-term living: low gravity. Utilizing materials that are easily accessible in the outer solar system, such as minerals collected from asteroids and smaller planets, these stations might be constructed on site. Moons and comets might also be used to extract water, ice, and volatiles at the same time. Solar mirrors might concentrate solar radiation into these habitats, supplying enough sunlight for plants to flourish, with the possibility of being turned off to produce a day-night cycle. Space-based solar, nuclear, and fusion reactors might provide all the energy required. Because of the planet's proximity to Uranus and Neptune, there would be an abundant supply of hydrogen and helium fuel. By mixing asteroid rock material, organic compounds produced from methane, and nitric fertilizers to generate soil, functional biomes might be developed within the dwellings. Water, ice, and ammonia could be used to generate oxygen and nitrogen gas, which could then be pumped into the atmosphere to form it. Then it would be possible to add plants, shrubs, trees, and animals to form a fully functional and regenerative ecosystem. In this ecosystem, plants would produce oxygen gas and remove carbon dioxide from the air, while the soil and plants would establish a nitrogen and water cycle like we have on Earth. There would be the provision of space stations, which would serve as a base for robotic or human haulers to gather materials for use. If useful resources like diamond, gold, and platinum remain valuable, prospectors might reach out to collect them. These might also be employed as supermaterials to construct spinning dwellings in space and on the ground, particularly if clear parts are required to emit concentrated sunlight. A robust economy focused on resource exploitation and tourism might be established over time. Bases in the outer solar system would also be perfect for conducting many forms of scientific study. That would be quite the predicament we'd find ourselves in. But do you think we humans have what it takes to save ourselves from this impending doom that may befall us? Tell us in the comments section below. And as always, thanks for watching Factnominal. We'll see you next time.